gathered here. We all have one goal, that is to conserve nature. More say, to not disturb its wilderness. We as human beings who coexist with ecosystem aren't fixtures. Instead, we strive to make sure nature's true potential doesn't get lost in the new world. The exceptional resilience being their true potential, we as a team aspire to create a world where the environment doesn't need protection. We, Biodiversity Conservation Foundation, India, as a team ensure passionate involvement towards conservation of wildlife and nature resources. Our team also works in creating awareness among common people and drive young minds towards conservation. We strongly believe that awareness is the major factor that helps people understand the natural world and diverge them from mistreating it. With more than 35 webinars collaborating experts from around the globe, this platform connects the volunteers holding various degrees of environmental knowledge varying from low to high with international experts. The team actively held numerous webinars about the biodiversity of water, land, and air during the lockdown, ensuring the conservation and awareness carried out independent of the pandemic. And of course, our journey doesn't stop here. We extend our role through various research-based studies and on-field conservation measures. We actively encourage our young minds and involve them in projects that can nurture their knowledge and skill. Our team has grown tremendously ever since the establishment of BCF. I welcome you all once again for the webinar on role of geospatial technology in conservation of biodiversity. Over to my colleague Ms. Marina Johnson for introducing our honorable speaker, Ms. Linda Kathambi Kirera. Welcome, ma'am.
Good evening to all. On behalf of BCF India, I, Marina Johnson, intern of BCF, privileged in introducing our today's speaker, Ms. Linda Kathambi Kirera, GIS mapping expert, Alliance Land Surveys Limited, Nairobi, Kenya. She took her bachelor's in geospatial engineering and master's in urban and regional planning from University of Nairobi. She worked as surveyor and GIS analyst in GeoServe Systems Limited in the year 2013. From 2013 to 14, she was GIS specialist in the Ministry of Nairobi Metropolitan Development. From 2015 to 16, she was photogrammetrist, assistant surveyor on consultancy services for digital topographical mapping and the preparation of integrated strategic urban development plans for various towns in country government of Turkana, and photogrammist in consultancy services for digital topographical mapping and preparation of Nakuru Spatial Development Plan of Nakuru country government. From 2016 to 17, she worked as assistant surveyor and photogrammist in consultancy services for geospatial survey and preparation of local physical development plan for the Galana Kulolu for security improvement project of Ministry of Water. From 2013 to 19, she was photogrammist and land surveyor in GeoMaps Africa, and some of her projects participated include consultancy services for digital topographical mapping and preparation of Kajiado from 2017 to 19, and photogrammist in Country Spatial Development Plan for 2016 to 2026 of Kadiajo Country Government. Currently, she is part-time land surveyor and physical planner in Alliance Land Surveys Limited, Nairobi, Kenya, and Geographic Information Systems consultant in freelance. Some of the projects participated include, now ongoing, she is GIS mapping expert in the project Provision of Consultancy Services for Preparation in Urban Areas Land Use Plans of Country Government of Tana Rivers. In 2019 to 2020, she as cartographer or card expert in the project provision of consultancy services for amalgamation, subdivision, and regularization plan for Naga Kihotu in Kaguzi Mitubiri Award, Moran Country for Naga Kihotu Farmers Cooperative Society. From 2019 to 20, she was GIS expert in the project consultancy service for road survey and title survey of Lanet Nyoro, town of Timboro, Road section of Kenya. Her technical skills include airborne lidar data processing, which include ground and non-ground classification, contours generation, feature extraction from last files, modeling, trajectory, and ploncon processing using Rigel software, digital aerial mapping and image processing using Ultramap software from Vixel Imaging in conjunction with Trimble Info software to produce orthophoto mosaics, establishment of ground control using GRX static GPS and RTX GPS surveys, application of AutoCAD, ArcGIS, QGIS, Global Mapper, PostPack MMS, Info, Reprocess, Ultramap, Spectra Precision, MicroStation SPSS, and GNS solutions for the creation and management of spatial data and related attribute information, use of digital data collection tools such as ODK, preparation of land use development plans through the application of participatory GIS, and conversant with the relevant research method as to carry out successful projects. BCF is happy in connecting the eminent professionals, stakeholders, students, and public on this international webinar during this COVID-19. We are delighted to connect our eminent speaker, Ms. Linda Kathambi Kirera, GIS mapping expert, Alliance Land Surveys Limited, Nairobi, Kenya, on this virtual forum and waiting to listen on role of geospatial technology in conservation of biodiversity. Over to you, ma'am. Thank you all.
Good evening, everyone. Yes, as I have been introduced, I am Linda Kathambi from Nairobi, Kenya. It's afternoon here. I understand it's already in the evening in India, but it's just around 1:43 here, and I am happy. I am happy to be with you today to be sharing about geospatial technologies and how it can be used to aid in conserving in the conservation and management of biodiversity for sustainability in our world today. Thank you so much, Biodiversity Conservation Foundation India. I am very much pleased to be with you today. So once again, everyone, welcome to this international webinar that is organized by BCF India. And yes, much has already been said about it, but it's a foundation that was established in 2010, and their mission. I'm happy to be part of this because they share common interest in that their mission is consistent efforts to conserve the diversity of an ecosystem and to promote ecological security. And their vision is to this year visualizes a society for promoting and assisting in healthy coexistence of human and wildlife and ultimately ensuring conservation of biodiversity. Welcome again. Like I said, I am Linda Kathambi and I'm here because I love geospatial technology and I'm enthusiastic about sustainable development. You can find me on LinkedIn and Twitter, to share more on this endeavor. So the topic for today is the role of geospatial technology in conservation of biodiversity, and I'll be focusing more on the forest ecosystems. So what is biodiversity? We all know that bio means life and diversity means variety. That is, the variety of animal and plant species that are found on our planet. And this is including the geographical location on where they are found. This is because not all species are found everywhere. They are specific somewhere, like when you think of Africa, you think of the lions or some other kind of species when it comes to plant and animals. And when it comes now to biodiversity conservation, the main challenges that are facing biodiversity mainly include pollution, population growth, consumption of resources, and climate change. And when it comes to the consumption of resources, you find there are normally conflicting interests, in how the human beings are utilizing the resources, even when it comes to in the forest ecosystems. So you find that as the human population is growing, our forests are being cut down, the trees, and what is happening is even in other areas now, the vegetation is being cleared, and a lot of soil erosion is happening, and this is now also affecting even our water bodies. So in deforestation, again, you find it drives animals, including birds, from their natural habitat, and you find that the habitat loss and degradation of grasslands and even the wildfires that face most parts of our world, especially Australia, and the deforestation. These are all threats to the well-being of the biodiversity. Now, what is geospatial technology, and just an introduction of it before we see how it can be applied in ending in the endeavors of conserving and managing and monitoring the biodiversity. So this is technology that relates to the correction or processing of data that is associated with location. So it just involves modern tools that contribute to the geographic mapping and analysis of the earth as well as the human societies. This is to talk of the natural and the built environment. Some common examples of geospatial technology include the GPS, that is the global positioning system. I'm sure we are all aware of it. When it comes to navigating, or even now when it comes to people in the landed profession, the surveyors, this is a technology that is utilized a lot when it comes to locating fixtures on the exact position on the Earth's surface. And there is also the remote sensing technology that mostly entails the acquisition of images, from afar, not being in touch with the imaging system. And the ultimate geographic information system, GIS, which enables the creation, organization, and presentation of data in a spatially referenced form, so as to produce maps, charts, and other ways of being able to easily visualize the information and data. And of course, we cannot forget about internet mapping technologies. Nowadays, everything is being put on the web when we talk of the cloud, and you find that the technology has advanced a lot, and now you don't even have to have it locally on your computer, on your desktop. All you need is internet, and you'll have the capability, you'll have the access and the softwares you need. They are the analytical capabilities which have been put online, and the data is also available so that you're able to carry out various analysis without having to undergo the cost of installing and buying expensive licenses. All you need is internet and a space in the cloud. So when we talk of, I'll focus more on the GIS, but we'll also be talking a lot on remote sensing later on in the presentation. But when you talk of the GIS, basically we are talking of the maps and the analysis and the data and applications. GIS it's basically a tool that helps in organizing information in a manner that you're able to interpret it as to make data informed decisions. When it comes to any development activity you have to take. This is just a sample workflow of the GIS. Where you have an imaging platform, which could be a satellite or unmanned aerial vehicle, and you remotely sense your images. And then also with GPS, you remember we saying that GPS aims in accurately locating pictures on the Earth's surface with the XY coordinates. And you carry out analysis, and this is where you're saying how you get the maps and the documentation and the evidence that you need so that you can make sound decisions. With GIS, we always have to start with the natural world, the environment, before we end up with maps or any other sort of data, whether it's vector or raster. And this is just a representation of the classical and the modern GIS, how initially maps were being made through the act of cartography, and now we have the and how you combine the digital photogrammetric workstation, and you arrive to various sets of data which could be in the vector. This is vector are represented in the form of points, lines, and polygons. And here you're able now, with the vector data, you're able to add a lot of other attribute information to your data, as much as you have, as much as you want. And you also have the raster, which mostly comprise of images, the aerial images, the satellite images, or even any scanned image that can be georeferenced and be incorporated in the GIS. And we already get maps, and we all know that maps, just like pictures, they're always worth a thousand ones. This is to illustrate the basic concept of GIS, where you need data, you need the hardware, the software, and of course the database, the storage, where you put all your data, whether it's the processed or it's data you want to process later on, or even the matic kind of data. And of course the administration now, the applications and the planning, and this is where now decisions ought to be made after, from the database you can do data mining, and the various administrators, where they have access to it, and they're able to carry out even more analysis and draw the data they need for the various decisions they ought to make. So why do we have to use GIS? We find that GIS, it really integrates information from various disciplines, whether it's cartography, remote sensing, or even any other sort of data that is stored in a database, and also graphics, and all these can be visualized in a GIS very easily. So you find that you're able to synthesize different types of geospatial data, and you're able, this kind of data, when you have different layers, you're definitely able to see patterns that could otherwise not be easily visible. And also now it simplifies the confirmation of observations by others. This to mean, like, for example, when you're even carrying out participatory GIS mapping, already when you have the base information, and you have now to involve the society, now it simplifies how they're able to confirm, because you already have some base information to share with them, and you're able to improve on it. So we find that GIS, it provides the base data, and this is data that can be improved on, updated, with time. And so it has the capabilities of analysis, such as modeling, and modeling is where you represent the situation of the world in form of models, so that you're able to carry out better analysis and to make better decisions. GIS, it's a tool that is all about making mostly data informed decisions. And also we have seen about the viewing of data. Now, when we are talking of the base data, or the GIS, and the data that's in it, you always have the base data, and we always have the thematic sort of data. Like, for example, now we are talking of the biodiversity. We know that there is the data that is specifically related to all issues to do with the biodiversity, but then you always have to have a base map from which now you can get the thematic data. This is data that is that is related to a particular theme, like now the biodiversity conservation or the protection of the environment. So we move on now to biodiversity conservation. We'll spend more time here, and we find that biodiversity conservation is closely related to other global environmental changes, and globalization issues are when we talk of climate change or land use and land cover change as well as sustainable development. So you find that it's human beings who have been changing ecosystems, and failure to take care of the nature, we find that now this has resulted in a declined biodiversity. So land cover change in forest ecosystems, we find that it leads to degradation of the forest, and this affects or lowers the level of carbon sequestration, thereby increasing carbon emissions into the atmosphere. And this now is what leads to the issues of climate change, global warming, and shortage of water, and either prolonged rainy seasons or prolonged droughts. So you find our world behaving in a very peculiar manner because we have failed in taking care of the nature, and this should not be the case. So when it comes to conservation of the biodiversity, remember we said that we biodiversity it mainly comprises of different plants and animal species, and they are all located at particular geographical locations in the world. So the priority should be, when it comes to conserving and managing the biodiversity, it should be the spatial delineation of the biodiversity rich and poor areas. In that, we need to understand, especially now when you're talking of the forest ecosystem, we need to understand the land use or the agricultural patterns of the forest landscape. And you find that GIS provides a way of overlaying different layers of data, like when you talk of the ecological conditions, or even the actual vegetation, and as well as human pressure indices. And it helps to assess the disturbance levels and the spatial distribution of several species in order to determine the status of the biodiversity. And then again, remote sensing, you find that we have the satellite images, and with such, we're able to have base information on vegetation as well as land cover. And this provides a special framework, upon which other vital layers can be put in or integrated together as to allow assessing and monitoring of the biodiversity. So I want us to look at a case study here in Kenya. It's quite a very important forest here in Kenya, and we are going to look at a part of it that is known as the Eastern Mau Forest Reserve here in Kenya, and it forms part of the larger Mau Forest complex, and it's really a major water tower in Kenya among the other four. It's one of the water towers we have here in Kenya. And for a long time now, this is an ecosystem that has been facing threat of degradation because there is a lot of encroachment to the forest, and it's being utilized in a manner that is totally illegal for a long time now. And this is to show you the extent of the forest that I am talking about. Yeah, it's somewhere in the Rift Valley parts of our country. And just to mention something about temporal satellite images, you find that these remote sensing images of the Earth they have really opened up new frontiers for management of biodiversity. In that these temporal images they provide information for vegetation mapping, monitoring, and also understanding of ecosystem function. So just to illustrate what I mean about the temporal images, this is an image covering part of this forest that I am talking about, the Mau Eastern Forest. This is an image of 1984. you can see that clearly you can see that the forest is covering quite a larger area, But now when we move on to this is a Landsat image for 1984. When we move on to an image for 2014, you can clearly see that the forest area has reduced incredibly. You can see that it has reduced incredibly. So these are the temporal. When we talk of the temporal, we mean we are talking of the time difference in images or time series images. And this is what is happening on the ground in this region. You find that people are settling and encroaching the forests and are subdividing land and farming, and yeah, this ought to be mitigated if this forest is to be saved, because now you find that even rivers are starting to dry up, and the again when you're talking of the climate change crisis, the trees are gone, charcoal is being burned within the forest, a lot of carbon emissions, and yes, it's just a disaster to the environment. So we continue with the case study, and so now what I want to illustrate here is how you can apply GIS and remote sensing technologies to carry out a land cover, land cover, change detection, especially in the forest ecosystem, to see how the vegetation cover has changed over time, so that you're able even to devise, what mitigation measures to put in place. So the primary data that is needed for such an analysis will definition the land cover types within that our study area. And the secondary data needed are or the ones that you can use. There are other various images that are available, but in this one we utilize the Landsat imageries. And the Landsat imageries are utilized here. We earned Landsat 4, which earned the 7 bands, in Landsat 7 and 8. And now here you see the characteristics of these Landsat images. We are talking of the spatial resolution. We are talking of the spectral resolution and the temporal resolution. What we mean about the spatial resolution, we can it's more to do with the ground sampling distance. Like when we mean over 30 meter, or if I was talking over 15 meter, the 15 meter could be the resolution, the spatial resolution could be much higher than this one over 30 meter. And this means that if I zoomed into the image, how faster do the pixels of that image become pixelated or blurry, or how much information am I able to see on the image. So you find that the meters here, the higher the resolution. But 30 meters is still as good for this sort of analysis. And when you're talking of the spectral resolution, this is all to do with this number of bands. When you're talking of the microspectrum, band for the images. And now the temporal resolution, this is all to do with the aspects of time. Like here, when it's written 16 days, like it means the fly through of the satellites to the same location. How long does it take to take an image of that particular location? So you find like all these ones, you find that it takes an image of a particular location every other 16 days. And just to mention, for the secondary information that is also needed, you can have the administrative boundaries. Like we have seen the delineation of the easternmost forest, and we can also have the population data and other attributes, even when it comes to the species found, species of plants and animals found within that particular area. So to continue now on to the methodology, how do you carry out this type of land cover change detection analysis? So the first step is to acquire the images that you need, and these are images that can be acquired from the United States Geological Survey, which in short is called the USGS website. This is free and open, so anyone can just access it and download information from there. These are satellite images. But now, for you to be able to know particularly where the images that you really need to download, you need to use this Landsat grid that is normally predefined, so that you're able to tell the path. The P here stands for path, and the row for the images that you need to download. So as long as your area of interest and the Landsat grid, they are all in the right, projection, you overlay them so that you're easily able to tell which images do you actually download. So the images that when downloading for this exercise are included an image for 1986, 1995, 2003, and 2014. So that because now we are more like doing a temporal analysis to be able to tell Kirera or rather the Mau Eastern Forest Reserve. So once you download the images, now you'll need to apply a few corrections. These are basically the radiometric and the geometric correction. The radiometric correction, this can be done in a software that is called NV software using the radius calibration tool. And what this correction does is that it removes the distortions that occur when the electromagnetic radiations interact with the atmospheric materials. And the geometric correction of this can be done in a GIS environment using like the ArcGIS software, the S3 ArcGIS software. And this is for removing shifts that appear between images because you find that these are images that have been taken probably by different sensors which are flying at different heights and different times at different times. So you find that when you overlay them, there can be a certain shift, and they are not on exact the same geographical location. So some geometric correction has to be done, and this mostly involves georeferencing of the image. And when we are talking of georeferencing, we mean the process of transforming these images as to appear in place now in the GIS environment. And this means associating these images to the real world X and Y coordinates. And this can be done in a GIS using the georeferencing toolbar, which is in the ArcGIS interface. And how you can do this, you can do it in two ways. You can either use an already georeferenced image that you have, maybe from your base information, or now you will have to actually now identify. The common thing is that you have to identify similar locations on the images that you want to georeference with the image that you're using, so that you're able to now overlay them well. Or another way is that now you can use GPS coordinates. So you identify this point. If you don't have the image, now you have to do some groundwork. So you identify a point on your image and get those GPS coordinates from the ground, so that now you come and load them and use your GPS Y and Z coordinates to georeference your image, so that it's now in the right geographical location in the GIS environment. So now the next step after you have georeferenced the images, remember we found that these are images that have several bands. So and each band is normally in the grayscale. So for you to acquire a color composite image, you need to combine several bands so that you have a color composite image. And then now once you have combined them, this is all done in the software. Once you have combined them, now you clip, you don't want to work with a large image that might slow down the processing capability. So you just clip it to your area of interest so that even you're able to the processing time can be made shorter. So you clip your area of interest, and you find that the image combined image band for this exercise beyond the green, red, and the near infrared bands, which give an infrared composite image for which is really very good for vegetation analysis. So these are the images, and this one is for the 2003, and the same thing for, sorry, this one, sorry, I'm a bit of mix up in the dates there. Yeah, this one is for 1995 years. This one is for 2014, and the other one, this one, we should have come in between the 1995 and the, sorry, yes, the 1995 and the 2014. And now just to mention something about these images, this is our area of interest. But you find the red part, it shows the vegetation, and where you find it gray, that means built. It could be buildings, or it could be tarmac. This is now the built up areas, and these ones they are standing for water bodies. And probably you're wondering, why is this water body light blue? This one seems dark blue. This one is also dark blue. This one is light blue. You find the explanation is that this water body right here, it's more shallow, and this one is it's deep. So this is all has to do with how the reflectance is acting. So you find that, for example, if you have a water body that is shallow, or it's muddy, or yeah, it has a lot of sediments, you find it's reflecting light blue. But if it's more clear, or it's more deep, you find it's dark, it's more dark blue. So why do we use false color composites? I mean, we have the true color images. Why do we have to use the false color composites? And you find that this is because they allow us to visualize wavelengths that human eye cannot see. The like the near infrared, like the near the infrared range. When you're talking of the wavelengths, when you talk of the micro, when you're talking of the spectrum, it's all to do with the wavelengths within the various bands and how they are being reflected. So you find that use of bands such as the near infrared increases the spectral separation, and this enhances the interpretability of the data. So that's why we use the false color composites when it comes to the analysis of vegetation. To continue with the methodology, now once you're done with combining of the image bands, now you have to classify those images, uh, the land cover types generation. And in this one, the object-based classification methodology by segmentation of polygons, around tertiary homogeneous areas of the image of used. So when you're talking of classification, we have the supervised and unsupervised classification. So basically here we are talking of the supervised classification. So this is where you use your, human eye, and you identify this region, and you think that, yeah, this looks like a building. So you create the class for that region, and this is vegetation. And so like you have to predetermine these classes. Like you have to set the targets before you carry out the classification. But with this one now, it's always after you've done that, it's always after you've classified your data this way, so that to make sure you have accurate results, it's always to do the field validation, which basically includes ground truthing. So this means that you just pick several points on your image. Yes, and the yellow points you see are these are points that are picked, and this gives the x and y coordinate for that particular point, and then you have to load these coordinates into GPS, and you have to visit now the field and verify that whatever that has been classified there is actually what is on the ground. So that is ground truthing, which is very important, so that to make sure that you have accurately done your classification. So with this one, we found that the results are within this Maoistern forest, the land cover types that were dominant here, or that are present here. We have the indigenous forests, we have the shrubland and grassland. Also, we have the plantain forest, cultivated fields, bare ground, and the built-up area. So these are basically the classes, that were found in this part of the eastern Mau forest. And the analysis results, they depicted that cultivated fields covering, from 1986 all the way to 2014, they had increased from 1% to above 47%. And the forest area and decrease, that is to do with the indigenous and the plantation forest, all that, and decreased from 43% to 36%, and also 34% to 7% respectively. So how you're able to calculate all these percentages, once you have done your classification, and you're now even able to have the information in vector form, it's very easy to calculate the areas for that. And this can be automatic in the ArcGIS platform. On the attribute information, you just calculate geometry, and you're able to find the areas. So you're able to tell initially the cultivated fields covered this acreage in 1986, but in 1986 it has increased, maybe from 1 hectare to 100 hectares. So that's how you're able to now arrive to the percentages as this particular land cover increased or decreased over time. So again, now also the grass and the shrubland are there decreased, that is from 16 to 8% and 6 to 2% respectively. And the bare ground and built up, it was the change was very minimal, both under tie at 1%. And the causes for pressure, that range to the degradation of the Mau forest mostly included crop cultivation, and then the settlement construction, and then the livestock grazing, as well as charcoal burning, and the need for the wood fuel, and the logging of trees, beekeeping, and medicinal herb extraction. So you find that there are very conflicting interests, when it comes to this ecosystem and the humans living around it. You find that the interests are totally competing, and that's why now it's resulting to the degradation of this forest. So to visualize these results, this is now Mau Eastern Forest in 1986, and you're able to see the green presenting the indigenous forests, and then the plantation forests. You have the shrubland and the grassland, and cultivated fields, bare ground, and the built-up area that is in black, all the colors. And this is in 1986. so as to be able to appreciate, why we need GIS, when it comes even to viewing of these such kind of information. When we explain to someone, it's good, but when they're able to visualize it, it's even more great. So this is in 1995. In 1986, yellow, focusing on the yellow color, which is standing for the cultivated fields, you find it's really very minimal, and the forest is covering more of the area of our interest. In 1995, you find that cultivation has started to take place. Going to 2003, there is a lot of encroachment and farming activities around the forest, and the forest area is being eaten up. And now, when again we look at 2014, it's worsening, and right now we are in 2020. It's all crisis in this area, and a lot needs to be done. So you find that GIS and remote sensing can be utilized. This is technology that is plays a major role when it comes to the conservation of biodiversity. Because now with such information, you're able to tell what is happening, where, and how is it changing over time, and you're able to devise better mitigation measures of what really needs to be done. Because now, like in this forest ecosystem, land uses, compatible land uses needs to be introduced that are not eaten up into the forest. Like if, for example, it was, an ecosystem that is to do with the water body, instead of people just doing agriculture all around it, you would advise that maybe they focus on the blue economy. That way, at least, these are land uses that are not having conflicting interests with each other. So you find that they are able to conserve the natural environment, and everyone, all actors that are involved are able to benefit without, without harming the interest of any other actor. So you find that remote sensing and GIS, they have these capabilities that can really be leveraged when it comes to biodiversity conservation, management, and monitoring. And so the RS and GIS are the end in determining the spatial and temporal extent of land cover change in these forest areas. We are talking of the spatial to do with a particular geographical location, and the temporal extent. How is it changing over time? Is it changing in a positive way or in a negative way? And where are these pressure points, and what can actually be done? So you find that land cover change in any ecosystem, it will always vary in space and in time. And GIS have these capabilities of determining these changes spatially and in a temporal manner. So again, as a recap, you find that satellite imagery, they facilitate the production of global land use and land cover maps. And these are maps that allow researchers to integrate, various sets of data uh, that is to do with imagery or even information data in any other attribute data in just one platform that allows for efficient and effective decision making. And when it comes to data and software availability, you find that there is a lot of remote sensing data that is freely available. And like we have seen in this case of the Landsat imageries, and we also have, depending on the other various, you know, um, aerial mapping platforms and satellite platforms that are out there, the Sentinel and the Mondis. And we also have the Google Earth engine. I mean, there are these other online web-based technologies that are also freely available, and they have these analytic capabilities, and anyone can be able to easily even calculate vegetation and other things necessary for conservation of biodiversity. And these cloud-based platforms, they provide you with not just the geospatial data sets that you need, but also the analytic capabilities. So I am coming to the end of my presentation, and just to conclude is to say that you will need past and present maps, when it comes to monitoring land cover and land use changes. This is because you need to understand the history. You need to know what has been happening, what is happening, for you to be able to more accurately predict what will happen in the future, so that you're able to have more sustainable mitigation measures that, yes, are going to be there for long. So you find that geospatial data helps in filling information gaps. When you have old maps, and you can build up on them with new geospatial data, and this helps in having a very strong database, from where now you can even get your thematic maps for creating biodiversity conservation plans. Again, satellite imagery combined with GIS maps, it's very essential for habitat and vegetation, as well as coastal mapping and monitoring and assessing, and also analysis, of the progress of conservation activities and ecological patterns, encroachment of encroachment of the protected areas. This is more like they're very useful when it comes to the management and the monitoring and the conservation activities of activities that are necessary for having a healthy biodiversity. And along with mapping the habitats and monitoring the changes that are happening, when it comes to the land cover in forest ecosystems, time-sensitive series of satellite images allows also researchers and scientists to estimate rates and patterns of deforestation in and around protected areas. So that brings me to the end of my presentation, by just to give you some hope. We find that in this current time, even though things may look like they're still bad, we find that our food has become safer, and our diets are becoming more diverse than ever before, and also our production methods, when it comes to agricultural production methods, can becoming more sustainable, clean and efficient, even when it comes to the kind of energy we are utilizing today. And we are consistently becoming better at protecting our biodiversity, and this is an endeavor that we should all take up, and keep on taking care of the nature, so that we can keep on taking care of us, and support largely the Biodiversity Conservation Foundation, because it's really doing very noble work, even in the creation of the awareness to do with what's going on with the biodiversity, and what can be done. So yes, we need to pull in more efforts, and work together, and I believe we'll be able to achieve everything that we aspire to achieve. Thank you, everyone, once again.